Recently, a discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, a well-known science communicator, made headlines when he announced that Voyager 1 had detected 300 massive objects in space. This revelation has not only ignited our curiosity but also raised profound questions. What exactly are these objects and where do they come from? Join us as we delve into the mysteries hinted at by Voyager 1's astonishing findings. For nearly 5 decades, the Voyager missions have provided some of the earliest and most extraordinary views of our solar system's wonders. Surprisingly, these missions weren't designed to last this long. Back in the 1970s, Michael Minovich had a groundbreaking idea. A spacecraft could use a planet's velocity to propel itself further into the solar system. Originally intended to last only 5 years, the Voyager mission has far exceeded those expectations. Launched just weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were first tasked with exploring Jupiter and Saturn. They accomplished this by providing detailed studies of these gas giants, but the journey didn't stop there. Voyager 2 went on to conduct the first ever close-up observations of Uranus in 1986 and Neptune in 1989. These historic flybys of 4 planets earned the mission the title Voyager Grand Tour. Instead of ending, the resilient spacecraft set their sights on a more ambitious goal, exploring deep space. Now, 46 years later, both Voyager 1 and Voyager 2 are still traveling and collecting crucial scientific data from the distant regions of the cosmos. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space, the region between stars beyond the Sun's magnetic fields and particle influence. It's like leaving the busy solar system and stepping into a serene, star-filled wilderness. This journey continued in 2018, when Voyager 2 also crossed into this vast region, located 17.7 billion kilometers from the Sun. Astonishingly, Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space, where they study how the interstellar medium interacts with the solar wind from our Sun. These pioneering missions have been our primary source of information about the heliosphere, a protective bubble that surrounds and shields our solar system. The heliosphere, shaped and influenced by the solar wind, a continuous stream of charged particles from the Sun, acts as a protective barrier for our solar system. Both Voyager 1 and Voyager 2 have served as our cosmic messengers, relaying valuable information about this celestial shield. All of this data converges at the heliopause, the outermost boundary of the solar system, marking the transition between the solar wind and the vastness of interstellar space. NASA's Voyager spacecraft have given us new insight into interstellar space. One significant discovery is that cosmic rays' mysterious high-energy particles are 3 times more intense beyond the heliopause than within the safer confines of the heliosphere. It's like comparing the calm of a quiet backyard to the busy energy of a bustling street. But there's more to this cosmic story. NASA didn't stop with the Voyager findings. By combining data from later missions with Voyager's observations, they created a more complete picture of how the Sun interacts with the surrounding interstellar space. In this grand cosmic dance, scientists made an unexpected discovery. In 2023, Voyager 1 detected a faint, low-humming sound that corresponded to vibrations in small amounts of gas drifting through interstellar space. Nicola Fox, head of NASA's Heliophysics Division, emphasized the importance of the Voyager missions, stating that over the past 46 years, they've provided invaluable knowledge, transforming our understanding of the Sun in ways no other spacecraft could. This incredible adventure in space is even more impressive considering the Voyager's power limitations. Both spacecraft are powered by a plutonium-based system. However, as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. To cope with this challenge, NASA has had to make difficult decisions, shutting down non-essential systems, even heaters designed to keep instruments warm in the freezing void of space. Astonishingly, despite these challenges, all 5 key instruments have continued to function since 2019, defying expectations. NASA scientists remain baffled by how the Voyagers are still operating under such cold conditions, where other spacecraft would freeze. This mystery adds another layer of awe to the legacy of these remarkable space pioneers, whose journey continues to surprise astronomers and deepen our understanding of the farthest reaches of our solar system. The heliopause, which marks the boundary between the Sun's influence and interstellar space, isn't static. Instead, it's shifting and forming unusual angles, leaving scientists both intrigued and perplexed. The idea that the heliopause might change shape isn't entirely new. Over the past decade, researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer IBEX satellite have observed its tendency to shift. These spacecraft provide crucial direct measurements of these cosmic boundaries, even if they can only capture a snapshot of a single location at a specific time. Dr. Eric J. Zarin, a space physicist from Princeton University, shared his excitement in an email to Vice, noting that IBEX has been supplying valuable data, helping scientists refine their predictions about the heliopause's future movements. What makes things even more intriguing is that recent studies have challenged long-held assumptions. In 2014, IBEX detected an unusual brightening of energetic particles, hinting at irregularities in the heliopause. However, these anomalies didn't fit current models, almost like an unexpected twist in the story. Researchers also noticed substantial shifts in the heliopause's position over a short period. This may explain why Voyager 1 entered interstellar space in 2012, followed by Voyager 2 in 2018, despite the 6-year gap. These surprising findings aren't just puzzling, they also contradict what scientists thought they knew about the heliopause. In May 2023, Voyager 1 experienced an unusual event during its operations. The spacecraft's attitude articulation and control system AX, which manages the direction of its high-gain antenna, began sending back confusing data. Instead of the regular updates on its health and status, it seemed like Voyager 1 was struggling to communicate, almost as though it were experiencing something akin to electronic aphasia, a kind of communication confusion. From Earth's perspective, it appeared that Voyager 1 was encountering electronic difficulties. The data Voyager 1 sent back during its recent anomaly seemed random and incoherent, as NASA described at the time. Interestingly, despite these strange reports, Voyager 1 itself appeared to be functioning normally. Its radio signal remained strong and stable, indicating that the antenna was still pointing towards Earth, contrary to what the AACs was suggesting. Adding to the mystery, Voyager 1's scientific instruments continued operating smoothly, unaware of the AX malfunction. Even the spacecraft's fault protection system, designed to place it into safe mode in case of issues, was not triggered. Fortunately, NASA quickly discovered the problem. The AICs had been using a computer that had been inactive for a long time. The solution was straightforward. They sent a command to switch to a functioning computer for data transmission. However, the cause of the AAC's strange behavior remained unclear. NASA speculated that an incorrect command from another onboard computer might have caused the issue. While this event didn't endanger Voyager 1, NASA continues to investigate to prevent similar problems in the future. Voyager 1 has been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This field, like Earth's magnetic shield, protects the spacecraft from cosmic rays and radiation, acting like a cosmic suit of armor. As with technology on Earth, Voyager 1's onboard computers occasionally face challenges from high-energy particles in space. Sometimes, these energetic particles can interact with computer chips, causing small memory errors that accumulate over time. Susan Dodd, project manager for both Voyager 1 and 2, offered a broader perspective on these challenges. She explained that encountering such anomalies is expected at this stage of the mission, given that these spacecraft have been on an extraordinary journey for nearly 5 decades, far exceeding their original mission timeline. Now navigating the uncharted territory of interstellar space, the Voyagers continue to be a source of wonder and discovery. The Voyagers, boldly venturing into space where radiation levels are incredibly high, face a daunting range of cosmic hurdles that no other spacecraft in human history has encountered. These remarkable probes have been on an extraordinary journey for nearly half a century, marking a milestone in the annals of space exploration. Since their launch in 1977, Voyager 1 and Voyager 2 have traversed immense distances, exploring the farthest reaches of our solar system and beyond. Their achievements are all the more extraordinary given the limitations of their 1970s-era technology. Each Voyager operates with a computer system equipped with only 70 kilobytes of memory, less than what is needed for a single modern digital image. Remarkably, NASA's engineers have managed to keep these distant spacecraft operational, continuously sending software updates across billions of miles to ensure their functionality. This monumental task is akin to providing cosmic support in the vast, silent expanse of space.